Alright, in this video we go over section 6.6, phase shifts. So in this case, in this section we are going to learn how to graph sinusoidal functions of this form, sine or cosine, incidentally, well, depending on the type of function that we have. But I mean, ultimately what this phase shift represent is nothing other than horizontal shiftings, which is something that we haven't done before, at least for as far as trigonometric functions go. All right. So well, let's bring back some of the definitions from the previous section. We know what the amplitude and the period is. Well, so we're gonna bring it to the conversation again, and phase shift is the new property for this kind of function, and is the quotient between phi and omega. Where is this coming from? Well, phi is going to be our horizontal shifting, and this omega is really our, if we bring back from these previous couple of sections, that represents the horizontal compression or stretching, right? So now this formula, where does that come from? Well, it comes from really setting the omega x minus phi, set that equal to 0. So for x, omega x equals phi, and x equals phi over omega. So this represents the phase shift. Nothing really, nothing really crazy. And I basically repeated the steps for graphing sinusoidal functions with phase shifts. Well, I mean, dividing into intervals and all that. Well, ultimately, what I would like to just show you how it looks like on the graphing calculator. But of course, we are going to look at getting the amplitude, the period, and the phase shift by hand, of course. All right. So in this case, let's label the givens right here. In this case, a for the amplitude, that's 3, and then omega, which is the number that multiplies the x, that's a 3, and phi, which is the number that that subtracts with x, right? That's pi. All right. So in this case, well, the amplitude, which is the absolute value of a, which is 3, well, that's what we get from here. And the period in this case, which is 2 pi over omega, that's 2 pi over 3. That means the graph will complete one cycle every 2 pi over 3 units. And then for the phase shift, I'm going to call it PS, just for short. That's the quotient between phi and omega. In this case is pi over 3. Or if you get confused with the sign, which might be the case, all you want to do is solve 2x minus pi, set it equal to 0, solve for x. Actually, this was supposed to be a 2, actually a 2, and in this case pi, my bad. All right, 2 pi, that's pi, x equals pi over 2. All right. Okay, so what is this going to do? Well, instead of going through the process of changing all this every single key point, well, if you want to do it in your leisure time, that's fine. But the ultimate goal of this is to understand the vertical stretching, the period, which is the horizontal stretching or compression. Also compression for there exists some compression for sinusoidal functions for the amplitude. I mean, we have talked about stretching only because we have had integers, but of course that could be a half or a third, and it will be actually a smashed graph. And the new property is the horizontal shift, which in this case pi over 2 units. So let's see what we're gonna get. So in this case we have a sine function. Let me start with a natural sine function. So in this case, sine of x And then over here, what was that? That's 3 sine of 2x minus pi. Alright, and this is, let's hit the graph. Well, that's our sine function. And then that's our shifted function. And notice in the one on the one hand, it's vertically stretched and it's also shifted pi units, pi over 2 units in this case, as the sign indicates, to the right. All right. So that's all we needed to do here. Let's do one more example, a very short example, one with cosine. Well, in this case, what is this going to do? Oh, by the way, before moving on, you might want to state the domain for this. The domain, you might be asked for the domain in the homework. Again, it's all real numbers, negative infinity to positive infinity, x such that x belongs to the set of all real numbers. As far as the range, well, in this case, notice how the graph goes from -3 to 3, and it's dictated by the value of a from the amplitude, -3 to 3, or y such that y is greater than or equal -3, less than or equal 3. All right. Let's move on to the next and last example. This is a very short section. Well, determine the amplitude, period, and phase shift of this given function. So our root function will be cosine function, right? So in this case, well, from the amplitude, absolute value of a, well, this is a, this is omega, and this is phi. And this is some, I believe this was B. All right, from the previous thing, yes, it was B, big B. All right, so what's going to happen here? Well, absolute value of A, that's the absolute value of 2, which is simply 2. That means potentially the range of the function is going to go from -2 to +2, but this +1, which will make the function be shifted up 1 unit, that's going to be changed. So let's have a look at the remaining properties. So p, the period, which is 2 pi over omega, and that's p, well, 2 pi over, omega is 4. So 2 pi over 4, that reduces to pi over 2. All right, so pi over 2. And then, well, in this case, the phase shift, well, I prefer to set the argument, or the angle, if you will, which is 4x plus 3 pi. I'd rather set it equal to 0. So that's 4x equals to -3 pi, and x equals -3 pi over 4. All right. So what is this going to do? Oh, well, I think that's about it. All right, so if I were to draw this by hand, okay, I'm going to do this example, only this example by hand, showing all the key points and all that. Well, so let me draw the graph of the cosine function, okay, using its key points. So to do that, I'm going to, let me see if I can find my ruler here. Well, I don't have it. I'll try my best to get this straight. All right, so that's going to be pi over 2, pi, 3 pi over 2, and then 2 pi. And then this is going to be 1, 2, 3. I'm going to have all the way to 4. -1, -2, -3, and -4. Okay, so the original cosine function has the following. Okay, I'm gonna do what I'm gonna do at the very end. For now, I'm not gonna care about this vertical shifting. We're gonna do that in the very end. So what I would like to focus on is first the well, let me do the original. That's over here and here. Well, that's actually gonna be here, like this. Well, it's not very pretty, but that's essentially cosine. That's 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, comma 0, and 2 pi, comma 1. Okay, so what are we going to do in this case? I'm going to shift all these points of the period is now pi over 2. So in this case, well, this is really big time. It's going to be really compressed. All right. So in this case, the graph is going to do one shift. Okay, let me use a different. Oh, I'm going to use the same pen. So I'm going to divide this into 4 exact, and it's going to look like this. It's going to be compressed big time. That's only one period with this compression, right? So that's only one. And then what's going to happen? Well, it's going to be a little bit hard to interpret. Well, pi over 2 divided by 2, that's pi over 4. And then this is pi over 8. And then this guy is 3 pi over 8. All right? This point right here is this one. This point right here is that one. Okay, well, I mean, I'm only doing one period, but of course this is going to go many periods. Okay, then from here, negative 3 pi over 4, that's the phase shift. That means all the x values, I need to move them 3 pi over 4 units. So what I usually do, I just shift this point and then that point and then that point and then that point. It's a little bit hard to do, so all I'm doing is shifting 3 pi over 4 units to the left, and then everything finally 1 unit up. All right, so let's see what's gonna happen. So I'm gonna do the graph of this over 1 period for the second. It should look something like this. Okay, let's see. Let me don't let me down. Okay, so I'm gonna have first the original cosine, function, cosine of x, and then 2 cosine of x, well actually 4x plus 3 pi, and then plus 1. Do not go to graph yet. Let me go to window. Okay, so x-min, well, in this case, I would like to do each line by pi over 8, each scale by pi over 8, and have x-min go from negative pi over 2 to pi over 2. That's what I'm going to do. Negative pi over 2 to pi over 2. All right. And well, the x can I already have. The y-min, well, I need to change that. I'm going to go, well, the amplitude is only 2. Well, and there's a shifting, so I'm just going to go from negative 4 to 4. Okay, y scaling is 1, that's fine. All right, so first I'm gonna get See how I get only this portion for the original? For cosine, I get only that portion of graph. And see how I also get this one right here? It's a little bit shifted, right? And that's how the shifting looks for this, how all the shifting, the period, and the amplitude. But again, graphing this by hand is usually a little bit tricky. Ultimately, what we need to understand is what amplitude is and what does it do to the graph of the trigonometric function, what the period is, which is the value of x at which the graph completes one cycle, and whenever the case is the phase shifting, which is in this case ultimately no other than a horizontal shift either to the right or to the left. So this is the end of this section. I think it's a good place to quit. I'll see you in the next section.